In this video, you will learn about how we are trying to design a way to power vehicles of the future on hydrogen, oxygen, and sunlight. Life, as we know it, is fueled by energy from the sun through the process of photosynthesis. This releases oxygen into the atmosphere and forms biomass from the water and carbon dioxide which enters the leaves of plants. When living things need energy, they simply rejoin the oxygen to the biomass, which we will call fuel, to reform carbon dioxide and water. We can mimic this by using electricity to split water into hydrogen and oxygen. The oxygen is released into the atmosphere, but the hydrogen is stored as a fuel for motor vehicles. In order to obtain energy for the vehicle, we need to rejoin the hydrogen with oxygen, and this is done most efficiently in what is called a fuel cell. In an ordinary electric cell, a metal, say zinc, ionizes at one electrode, the anode, giving off 2 electrons. The electrons are pushed around the circuit, carrying energy to, for example, a motor, and are absorbed by metal ions of a less reactive metal, say copper. The circuit is completed by the movement of metal ions through the solution. In a fuel cell, the reactants are gases instead of metals. Hydrogen gives its electrons. The electrons flow round, driving the motor, and arrive at the cathode, where they are recombined with hydrogen in the presence of the reactive gas oxygen, which provides the driving energy to form water again. The electrodes can be made of porous carbon coated with a catalyst such as platinum or nickel. The advantage of combining a fuel and oxygen in a cell is that you can, in theory, convert most of the chemical energy to electricity, whereas burning them, as happens in the internal combustion engine of a car, has a maximum efficiency of about 50%, and in practice only about 25% of the chemical energy does useful work in driving the engine. The rest comes out as waste heat. There are 2 major problems to using hydrogen fuel cells in vehicles. Firstly, where do you get the hydrogen? Currently, most industrial hydrogen is derived from methane, and the carbon is rejected as carbon dioxide, thus adding to the greenhouse effect. The hope is that we can learn to mimic photosynthesis by using sunlight to split water molecules apart, giving us a clean and simple source of hydrogen. Currently, this is achieved by using photovoltaic cells to generate electricity, which then electrolyzes water, forming hydrogen and oxygen. To take the analogy further, the hydrogen is transported to the fuel cell, like biomass passing along a food chain, and the oxygen, which we tend to take for granted, is vented to the atmosphere. The fuel cell then gets its oxygen from the atmosphere, just like in respiration. The energy is stored whilst the hydrogen and oxygen are kept apart. The other problem is how to store and transport the hydrogen gas once you've got it. It's extremely difficult to liquefy and rather dangerous if kept as a gas under pressure, particularly if the vehicle crashes. Research is therefore focusing on hydrides, compounds of elements with hydrogen, which are solid or liquid at room temperature and which give out their hydrogen reversibly and without too much energy input. This allows hydrogen to be pumped in, reacting to form the hydride, and then, on the journey, the hydrogen is given off to be used in the fuel cell to drive the vehicle. For example, ammonia borane, a solid at room temperature with the same structure of ethane, gives up its hydrogen on heating. However, it will probably be more energy efficient to run the cars on batteries, which are charged from green electricity. So to summarize, fuel cells generate electricity from the reaction between a fuel and oxygen. Using them on vehicles means that we need to develop a way of storing hydrogen, which is difficult. So vehicles of the future are more likely to be powered by batteries.